Hey everyone, and welcome. So today, we are pulling back the curtain on generative AI. We've all seen the raw power of large language models, right? It's mind-blowing stuff. But what does it really take to get that power ready for a real business? Make it safe, reliable, and something you can actually count on. Turns out, it's a lot more involved than you might think.
And yeah, that really brings us to the heart of the matter. A plain old LLM straight out of the box? It's kind of like a creative genius, absolutely brilliant, but also completely unpredictable. So how in the world can you trust it with your company's most sensitive financial data, or your customer lists, or your secret internal strategies? The stakes here are, well, they're incredibly high. Okay, so let's dive right in. The absolute best way to get our heads around these complex systems that make AI ready for the big leagues is to just follow one single user request. We're going to see its entire journey, all the checks, all the hoops it has to jump through before it ever even gets close to an answer.
So, the real challenge, the core of the problem, is turning that raw, creative spark into a predictable, production-ready tool. Think about that brilliant but erratic genius again. To make them an effective part of a team, you wouldn't just let them run wild, right? No, you'd build an entire support system around them, a whole framework of rules, knowledge, and safeguards. It's the same idea here. And this is exactly what we mean when we say enterprise grade. It's not just about the AI model itself, it's about the entire architecture you build around it. The source material really nails this down to three key pillars. It has to be governed, meaning it plays by the company's rules. It has to be scalable, so it can handle the workload. And, of course, it has to be secure, to protect all that important data.
All right, so where does our user's query even begin its journey? Well, the very first stop is what you can think of as the front door of the system. It's a digital gateway, where that query has to prove it belongs there and, just as importantly, that it isn't some kind of threat. This little flowchart gives us a great bird's-eye view. See, the user's question doesn't go straight to the AI's brain, not even close. First, it hits something called an API gateway, which is basically a bouncer at the door. Only after it passes a bunch of initial security tests can it move deeper into the system.
And here are those security checks in a bit more detail. First up, authentication and role-based access control, or RBAC. This is all about checking who the user is and what they're actually allowed to see. Then you've got the policy engine, making sure the request itself is playing by the rules. Rate limiting is there to stop anyone from spamming the system. And, this is crucial, it's also scanning for malicious attacks like prompt injection and automatically masking any sensitive personal information, that PII, to protect privacy.
So, once our query is verified, cleaned up, and deemed safe, it's time for the next big step, giving the LLM the information it needs to give a correct answer. See, a raw LLM knows nothing about your company's internal files. That's where something called Retrieval Augmented Generation, or RAG, comes into play.
Now, this diagram shows the whole RAG architecture. I know it might look a little complicated at first glance, but it's really just a two-step process. Step 1 is all about preparing your company's knowledge, and Step 2 is about using that knowledge to answer a very specific question.
Let's break down that first step. So, a document loader sucks in all kinds of company data. Think PDFs, reports, you name it. Then, a text splitter cleverly chops those documents up into smaller, logical pieces. After that, an embedding model works its magic, turning these text chunks into numbers, into vectors. It's like giving every single piece of information its own unique coordinate on a giant map. Finally, all these vectors get stored and indexed in a special vector database, all set for a super fast search.
Now we're on to Step 2. When our user's query finally gets here, the system does the same thing to it. It converts it into a vector. The DB retriever then zips over to that vector database and finds the document chunks with the closest coordinates. A re-ranking step then makes sure only the absolute most relevant info is chosen, before the system bundles up the original query with this new data into a brand new, supercharged prompt for the LLM.
And this is why RAG is such a game changer. It's the secret weapon against one of the biggest headaches in AI, hallucinations. When the AI just makes stuff up. By grounding the LLM in the company's own factual data, the system makes sure the answers are actually accurate and relevant. It's a huge deal.
Okay, but what happens if a question is too complex for just one search? What if it needs to do multiple things, like run calculations or talk to different systems? For that, we need to go beyond a simple RAG pipeline. We need to assemble a whole team of specialized AI agents.
At the core of this team, you've got two main players. First, there's the planner agent.
This one's the strategist. It takes a complex request from a user and breaks it down into a logical, step-by-step plan. Then you have the executor agent. This one's the doer. It takes one task from the planner's list, like call this API or run this calculation, and it just gets it done.
But a full-on agentic team has even more specialists. There's a retriever agent that goes and fetches knowledge, pretty much like we saw in the RAG pipeline. You've got a validator agent that double-checks the final answer to make sure it's accurate and safe. And then, watching over the whole operation is the supervisor agent. Think of it as the project manager, making sure the whole workflow runs smoothly and keeping the other agents from getting stuck in an endless loop.
So we've designed the brains of our AI system. Awesome. But now we have to build the rest of it. How do you actually deploy and manage this whole complicated setup in a live, real-world business environment? This diagram really brings it all home. You can see every piece we've talked about. The user queries coming into that API gateway, the RAG engine doing its thing, the team of agents ready to work, and the data ingestion pipeline that's constantly feeding the system new information. And it all sits on a solid foundation of cloud infrastructure. And making the system tough enough for the real world takes a whole toolbox of operational gear. It's deployed on secure cloud platforms like Azure. You've got CI/CD pipelines to automate updates and keep things reliable. Observability and logging systems are watching everything, from performance to costs. Kubernetes helps it scale up or down automatically. And a caching layer saves common answers to make things faster and cheaper.
So at the end of the day, what all this really shows us is that building an AI business can depend on, it isn't about just picking the single smartest model, not at all. It's about being a master architect, carefully designing, building, and maintaining this complex, interconnected system where every single component has a critical job to do to deliver a result that's secure, reliable, and trustworthy.
So, we've followed our query all the way through this journey. We've built this incredible technical system that's powerful, secure, and grounded in facts. But this just leads us to an even bigger, even deeper question. Now that we can control how the AI operates, how do we make sure that what it does is truly aligned with our company's values and, with human goals in general? Well, that, my friends, is the next great frontier.